So last day, after the quiz, we did a little bit of notes, and what I wanted to highlight was the first step that we typically do when we're solving, is when we add and subtract a term. And I wanted you to notice that the term that we're adding or subtracting usually shows up as the opposite on the other side. And that's the point I wanted to bring up to help making solving equations maybe a little bit faster. Right, so let's look at some solving here and remind you where we were at. So let's do this one here. I don't think we did this one, did we? Oh, we did. Oh, where did we go? I'm looking at Abby's here. Okay, this question here. Okay, so the first decision you need to make is what side do you want to collect your x's on, the left side or the right side? Right, so this question here, where do you want to keep your x? On the left side or the right side? Make that decision.
Left.
Left, okay. Then we got to go, okay, if it's not an x on the left side, it's got to move to the other side. So going across here, this x is fine over here. This 5 needs to move to the other side. So we're going to move it, we're going to collect our x's on the left-hand side. How does the 5 look like on the other side? Minus 5. So we can just take this 5, move it to the other side, and cross this out. Okay? Then we just do this cleanup. We have x over 2 equals 9 minus 5 equals 4. And then we just do our math as we normally did for solving equations. We need to get rid of that 2. How do we get rid of that 2? Multiply, divide, add, subtract. How do we get rid of that 2? Multiply. A 2 on the bottom gets canceled out by a 2 on the top. So multiply by 2. The 2's are gone. X is equal to 4 times 2, which is 8. Okay? All right, so I'll do this one with you, then I'll have you do the other one. All right, so with this question here, what side do you want to keep our x's on, left or right?
Left.
Left, all right. So the 2x over 5, that stays there. The 6 needs to go. How does it look like on the other side? Plus 6, minus 6? Minus 6. Thank you, Chase. And we cross this out and we rewrite it all cleaned up. We have 2x over 5. And what do we write on the right-hand side now?
Negative 4.
Negative 4. 2 minus 6 is negative 4. Okay. Now back to side of the x's. The 2 and the 5 need to go. This was one of the trickier ones. How do we get rid of the 2 and the 5? Who remembers that maneuver? What do we multiply? What do we divide?
You multiply 5 over 2.
Yeah, we multiply by 5 over 2. 5 on the top will cancel the 5 on the bottom. 2 on the bottom will cancel the 2 on the top. And whatever we do to one side, we do to the other. Or when we're multiplying, everything gets multiplied. And if it helps you, make it a little over 1 here. So the 5's cancel out. The 2's cancel out. We're left with the x. And what do we have on the right-hand side?
Negative 20 over 2.
Yeah, 4 times 5 is 20. And don't forget the negative sign over 2. Now that's a fraction we can clean up. This 2 can fit into 20 10 times. So x is equal to negative 10. Okay, so try this one on your own. And I'll come around and I'll help you. Glad to see that most people are getting this. Just you need to be very careful because the main error I see is people not changing the sign. So opposite side plus 5, 3x over 2 equals 13. Need to get rid of the 2 and the 3, 2 on the top, 3 on the bottom. Whatever you do one side, you do the other. Those are all gone. 26 over 3. Now, this approach here, it doesn't really make too much of a difference compared to what you've been doing for these kind of questions. Because they're quite small, so writing plus 6, minus 6 on both sides is not that big of a deal. But when you go to the back side, and you get more terms happening, this method becomes a little bit more efficient. Okay? So the process is still the same. It's all about collecting like terms, like we did in November and December in the polynomials unit. So if you have a question like this, and we want to organize our equation with all of our x's together and all of our numbers together. So the first decision is, where do you want to put the x's? Left side or right side? Right? And there's no right or wrong way. Sometimes one way is faster than the other way, but you'll still get to the same answer. So, Abe, left side or right side for the x's? Left. Right? So, we're going to put our x's here, and our numbers are going to go over here. Okay? Now, I'm going to look across now. Okay? And I'm going to rearrange the terms. And remember, if a term needs to move, it becomes the opposite on the other side. So, looking across here, does the 4x stay here or go to the other side? Oops, sorry? No. We decided we're collecting x's on this side. So that's an x, it stays here. Does the 5 stay here or go to the other side? Goes to the other side. I'm just going to highlight this for now. I'm just going to make note of it. Does the 12 stay on this side or go to the other side? Stays. We reflect our numbers here. So it stays. And how about the 2x? Does it stay or go? This one. Goes. Because we're putting our x's over here. Okay? So everything that stays the same. So the 4x stays the same. The 12 stays the same. All right? Everything that goes becomes the opposite. So the 5 was on the left side. It's going to move to the right side. So how's it going to look like on the right side?
12 plus 5.
Not 12 plus 5.
12 plus 2.
Minus 5. It's positive 5. It turns to minus 5 on the other side. Right? Changing sides of the equation. Right? How about that 2x? It can go from here to here. How does it look like on the left-hand side? Minus 2x. Okay? So now, if you notice the equation, we have all x's over here, all just numbers over here. So we moved all of our like terms together. Now we simplify. We have our x's over here. We can add those together, or in this case, subtract. What is 4 minus 2? Right? Sorry? 2. 2x. So this is like what we did in December. Okay? What is 12 minus 5 on the other side?
7.
Good. Okay, now, are we done? No? Jacob, what do we need to move?
Get rid of the 2 by the x.
Get rid of the 2 by the x, and how do we get rid of it?
Divide.
Divide by 2. 2 on the top gets canceled out by a 2 on the bottom. Whatever you do to one side gets done to the other. Right? X is just 7 over 2. Right? Much faster, isn't it? At least I think it is much faster. Right? And there's different ways of sort of figuring out what works for you best in your head, how to remember what stays and what goes. Right? I just do what works for me. But you should find out what works for yourself, how to remember. So I'll do another technique as well for this next question. Okay? So first decision you need to make is what side do you want the x's on? Left side or the right side? Where do you want the x's?
Left.
Left. So I'm going to put x's here, numbers here, just so we know. So another way to think about it is just read left to right and move the numbers if you need to, or keep it where it is. So 9x, does it stay or go? Stays. So I'm going to put a 9x here. I'll put an equal in the middle here. Next number, 2. Does it stay or go?
Go.
Go. I'm going to cross it off. How does it look like on the other side?
Minus 2.
Minus 2. It's plus 2, minus 2 on the other side. Okay, reading from left to right. 7. Does that stay on that side or go? Stay. So that's a positive 7. So I'm going to write down a plus 7. Okay? The x here, does it stay or go?
Go.
Go, it changes signs. It's negative 2 over there, becomes positive 2 over here. Okay? So it just changes signs as you go from left to right. So combining the x's together, what do we get?
11.
11 and the x. Combining the numbers together, what do we get?
5.
5.
Negative 5.
Nope, positive 5. Negative 2 plus 7 would be positive 5. All right? Then what's next? Divide by 11 to get rid of the 11. Good. I like how natural this is becoming for a lot of you guys. So 11s cancel out, and we leave our answer as just 5 over 11. Okay. That's good. That's great, actually. Okay, try this one all by yourself. All right? What number do you come up with? The people are not here, so I'm going to quickly do this. Okay, so most people decided to put the x's over here and the numbers over there. First 8x, that stays over here. Looking across, the 7 is going to move to the other side. This is a minus 7 or negative 7. You need to include the sign that's in front of it, so that becomes a positive 7 on the other side. You write down a 7 or a plus sign there, doesn't really make a difference. And going across, the 6 is on the 6x is on the wrong side. You want the x's on the left side, so that'd be a negative 6x over here. Okay, and now with the 4. This is where most people made the mistake with the 4 here, is they kept the 4 on the right side, but they wrote down positive 4. This sign here, even though it's a subtraction sign, it's also a negative sign. So that belongs to that 4. Whenever you have a symbol, it belongs to the number right after that symbol. So that negative has got to stay there. Okay? So 8 minus 6 on the left side is 2x. 7 minus 4 is 3. Just divide by the 2. And x is 3 over 2. Which is great. So I think you guys are getting this. And I don't want to spend too much time on it. But let's just do a harder one together. We'll do these two together. Or we'll do this one together. And we'll have you do the harder one. But if you are understanding this, you don't need to wait for me. Just go ahead and just look up. But if you're having a little bit of troubles, I'll just talk with my way through. But I'm going to expect the class to do this question. All right, so I'm going to start off here. All right. So I want to collect my x's on the left side, my numbers over here, and I'm going to read across. And I put my little equal sign. So the 5x is on the right side, is where it needs to belong, so I just leave the 5x here. The 6 is on the wrong side, so I look at the sign in front of it and I change it to move it to the other side. So I'm going to do that as a minus 6. Then I look at the 2x. Oh, that's the same side that needs to be on the x's, so I keep it over here, include the sign that is in front of it. So that's the minus sign that's in front of it. Then I go look at the 9. The 9 is on the wrong side. It needs to go to the other side, so we change the sign from positive 9 to negative 9 to the other side. Okay. Walking across the equal sign, we look at the 4. And the 4, hey, this is the side we're keeping our numbers on, so it stays here. Now that the 4 doesn't have a sign on it, but that is a positive 4, so we just do a plus 4. Then we look at the 6x, that's on the wrong side because we want x is all on the left side. So we move it to the other side. It was a negative. It's going to become a positive. Right? Maybe I'll highlight the negative sign as well, just so it's more clear. Oops, there we go. Then looking at the next term, we have a 3x. That's positive, and on the wrong side, so we move it to the other side, and it's going to become negative 3x. Then I have that 20 sitting there, and that's the side the numbers are going to be on, so that 20 is fine. So rewrite it as is, minus 20. Now, we need to combine our like terms. So just grab your calculator and just punch these numbers straight in as you see. Or you can do it in multiple steps if you want, but I would do it just at once, right? Less likely to make an error. So I have a 5 minus a 2 plus a 6 minus a 3. Just do it all in one go. And I end up with 6. So that is a 6x. Over on the other side, I'm going to combine all these together. I'm going to just punch them into my calculator all in one go. So I have a negative 6 minus a 9 plus a 4 minus a 20, and I get negative 31. Okay. So now I clean this up. Get rid of the 6 by dividing by 6. Dividing by 6. The 6's are gone, and x is equal to negative 31 over 6. And that's it. Okay. So try this one on your own. So you got multiple terms. Move the numbers around. What do you get? I think this is the first. Everybody got the right answer. This is fantastic. So I'm just going to write it down for the video for the people at home. The 7x stays. The 3x, the 3 goes to the other side, so that becomes a positive 3. The 2x stays, so that's a plus 2x. The 8 goes to the other side, minus 8. And the 15, that stays, so that's plus 15. The 6 stays, so that's minus 6. Okay. Now, the error that I encountered with students is sometimes they forget to move a term. Right? Like they'll be doing this equation and they moved everything correctly and they just forgot about the 8. So maybe for yourself, when you're done doing this, just count your terms. I have 1, 2, 3, 4, 5, 6 things written down here, and I have 6 things here. Right? If you count and you end up with 1 extra, maybe you double counted something, or if you end up with 1 less, you forgot about something. That's just a way to double check something. All right, so I combine these together. I get 9x. Combine all of those together. I think the answer was 4. And divide by 9. Divide by 9, you get 4 over 9, which is great. Okay, so now for the last little bit, I want to go to your day 3 notes. So grab these ones out. Do a little bit more notes and we'll call it a day. This is where life gets maybe a little bit more difficult, right? Because we want to introduce a different kind of equations. This time the equations will have a bracket, right? Now, the property we're going to use to solve this, we did this in like November, in December and January, right? So normally, when we have brackets, we just follow our BEDMAS rules, right? If you want to simplify this and combine our terms, we do the stuff inside the brackets. We go 3 plus 4, right? That gives us a 7. Then we have that 2 sitting on the outside, right? And we multiply those together, we get 14, right? That's stuff you've been doing since grade 7. Then in, I guess, December and January, we started looking at stuff like this. And well, we didn't have the equal sign. And the problem with the brackets here was the 2 numbers inside, or the 2 terms, they're not like terms, so we couldn't add them together. So we needed a workaround to get rid of the brackets. Right? And the workaround was something called the distributive property. Right? And this is where we did all those little rainbows. Right? And what we said is, hey, we can distribute that 2 on the outside to everything on the inside. So we went 2 times 3. We can go in this order, right? And we wrote down that's equal to 6. And then we went 2 times 4. That's 8, and we have a plus sign between them. And we had 6 plus 8, and we still get 14. So the distributive property was just another way of doing our calculations without necessarily having to follow the BEDMAS order. All right, Evan, you remember that?
Yeah, I do.
Okay, so now we are going to do the same thing over here. Because we can't combine the stuff inside the brackets, right? So we need to, in order to be able to solve at the end of our equation, we need x on one side and all the numbers on the other side. So we need to get rid of all these brackets. So we use our distributive property. So we take the 4 from the outside and you multiply it to everything on the inside. So you got 4 times x. What is that? Just a 4x, yeah. Right? Then we go 4 times the second term. This is an important one because most people forget the second term, right? And since it's a decimal, we just use our calculator, right? You go 4 times 0.6, and I get a 2.4. Now, there's something missing here, right? When we have terms, we need a sign between the terms. What sign should go between the 4x and the 2.4? Lachlan? Minus. Because we had a minus here. 4 times negative 0.6 is negative 2.4. All right? Now we have that equal sign and the 3.2. Okay, so now we get to solve. Right? So the decision you need to make is where do you want your x's? Left side or right side? I heard somebody say left side, right? Makes sense. They only have one x. It's already there. Why move it? Right? So we're going to keep our x's over here, and our numbers are going to go over here. So the 4x stays. How about the 2.4? Does that stay or go? Sorry, Abby? Goes. And how do we write it on the other side? Plus. Right? So we go, well, you can cross it out here if you wanted to, and just go plus 2.4 over here. All right? Now we do that calculation. What is 3.2 plus 2.4? 5.6. Thank you. Okay, what's our next step? Lachlan?
You divide by 4 on both sides.
Yeah. To get rid of the 4, you divide by 4. And you divide by 4. So the 4's cancel out. We have x is equal to 5.6 divided by 4. Right? So this is a decimal question, so we actually calculate that out. We don't leave it as a decimal fraction. So you just go 5.6 divided by 4, and you get 1.4. And that's it. Harder question. We've got brackets involved and everything like that. What was the difficulty feel like? Doable? That's what I'm looking for. All right. All right. So let's do this one together. All right? Because we need to go through a couple of these to remind you. So you see brackets. We want to get rid of brackets. All right? So we take the number on the outside, you multiply it to the inside. So I do my first arrow. What do I write down? 2x. I do my second arrow. What do I write down?
6.
Not 6. We're multiplying here. 8. Okay? We need a sign between these two terms. Do I put a plus sign or a minus sign there? Minus. This is 2 times negative 4. Minus sign. And we have that 12 sitting there. This 2 does not apply to the 12. Right? Sometimes people multiply the 2 all the way over there. Right? It's only touching the bracket, so everything inside the bracket gets multiplied by 2. Okay. So now, what side do you want the x's on? Left side or right side?
Left.
Left. So that 2x stays, The 8 needs to go. How does the 8 look like on the other side?
Plus 8.
Plus 8. It's minus 8 here. Goes plus 8 over here. And we cross that out. All right, like that. And we have 2x is equal to what?
20.
20. Okay. Now, are we done? What do we need to do next, Jared?
Divide 2 by 2.
Divided by 2. That's it?
No, then you divide 2 by 2.
Yeah. When you're dividing, everything gets divided. The 2's cancel out. X is equal to 20 over 2. And, yeah, because that can be simplified. 2 can fit into 20 10 times. X is equal to 10. Okay? So let's have you do this one. I need to change this question first because the same question is over on the other side of the page. So let's change this to a 3 here. And let's change that to a 1.2. Okay? So let's calculate this out. To everybody? Yeah. You multiply this through the brackets. 3 times x is 3x. 3 times 0.6 is 1.8. We keep that negative sign there. And it equals 1.2. We only have one x, so it makes sense to keep the x's on the left-hand side. That means we're going to move the number to the other side. That's a negative 1.8. I'll make a positive 1.8 over there. Right? So when you're showing this, like if you're doing it like this, please don't completely scribble this out. Right? Just do 1 or 2 lines through it so I can still see your work, because if you make a mistake, I can see what the number is. Right? So we have a 3x sitting here, and a 1.2 plus a 1.8 is a 3. You divide by the 3's. We have x is equal to 1. Okay, and we'll call it quits at that point. So we'll do a little review next day.